Hi folks, now I'm back, same day. Just did the, finished out the African precipitation PPT. And it's the same stuff that I have open now that I had open through that one. But now we're looking at the second one here, which is more going to focus on the Seychelles Vortex. So as I was saying in the previous one, the Seychelles Vortex is the oldest vortex that we can go by. And in this particular view, you can actually see how so many different things actually may have taken place under the right circumstances. Okay, and it's interesting how they turn out that way. These vortices, as we learned from Africa, these vortices have a major impact on scoring very large separations in the Earth's surface. The separation of Africa from Europe and the Middle East, right? So, because we were looking at that one vortical perimeter cutting right through the Red Sea right here. Makes a lot of sense now, right? All right. That's somewhat the center of that particular vortex. So this is Seychelles. This is going to be the Seychelles series, the very first, possibly the very first recorded series on the Earth, the surface of the Earth. And yeah, you can see how it cuts through up in here and around. Outside of the fact that Seychelles is here, it's really hard to see. The surface of the planet has changed in some ways since the Seychelles Vortex was active. But what didn't likely change is the evidence we see here where material would have come in through this direction here, just like on the sun, and it precipitated down into this vortex, which is rotating counterclockwise. So when your spiral density, little or huge, spiral density fracture rotates in this direction, you know that the vortex was rotating in the opposite direction than the drag that created your spiral density fracture. Okay, on the sun, it's like I refer to them as spiral density posile zones, but they're not really pausing. They're just fractures that aren't fractures because it's not something that's solid. It's basically the colder material underneath the corona becomes visible and leaves these spiraling little cinnamon roll marks all over the place. All right. Now, after I mapped this vortex and lined it up with some stuff up here, and I'm pretty sure I lined it up with some stuff that seems to be consistent with the center of the location of that. And we'll see. I gotta delete it first. Alright, so if I delete it, now I go back. Now, what I like about Google Earth is you map these circles on Google Earth, and then you can just sit there and go repetitively and very rapidly. Click it on, click it off, click it on, click it off. And as you're clicking on, clicking off, clicking on, clicking off, you wait for the light in your screen to dissipate, because after you click it off, it leaves a ghost of your line. You have to wait until the ghost of your line is completely gone by the liquid crystals or whatever it is to make them light up. And then you look at the Earth after it's dissipated, right? And then, so we've got this here. I put my circle back up there. Now I'm going to go on my right arrow and take it out. And, even if it doesn't match something perfectly on the perimeter, you cannot deny that Seychelles was indeed a vortex, right? It's like amazing stuff. So it doesn't really matter. But what you can see is the way you could basically understand how the Earth precipitated initially anyway. Okay, now we go to the next one here, and basically I'm going toward my left, or I'm going westward, and as I do, I place the next vortex over here in alignment with the Seychelles Vortex we have over here on the east side now in this view. And this is what I call the yin and yang Seychelles Vortical mapping. And I called it the yin and yang because even though the continents do not specifically appear to be in your precipitory form in this vortex, what you have is you have precipitation of the ocean coming down and going in the yin and yang formation here. And so you have the North Pole coming down from Greenland going over into into the United States and stopping right here, because this is Guacanayabo. This great big bump right here is the B2W. The B2W is the blast bow wave. 2 B's, 1 W. Blast bow wave. Right, so it's B2W. All right, now the B2W of the Guacanayabo impactor blocked any more mass from the continental mass from the North America to be drawn or precipitated further down into South America. So the greater masses of North America precipitating down came from over further west, down the Rockies, down into South America down here, and may or may not have submerged and re-emerged, like it went down and under all of this before it came back out to create this larger mass. It's interesting. Or this larger mass was larger in here until basically until the South China Sea impactor struck and caused these the asthenospheric tsunamis coming across the Pacific Ocean to basically re-emerge and create these channels of helical vortices in the Caribbean and in the South Sandwich Islands. Okay, yeah, it kind of looks like we could bring this a little closer to the eastern shore of the United States, but then it takes us away from over here, and then that means that this vortex would have to move west. But the really cool thing here is down here you can see how this particular mountain range down here, the subterranean mountain range, comes across. It's following that perimeter, right? This is good stuff right here, folks. And this tells us a lot about our planet and how it formed. And this is the planetary suture. Now we know why Earth's planetary suture is vertical and not horizontal. In my first theories of the suture, I would have suggested that the North Pole being colder, the South Pole being colder, they would have solidified first, leaving a molten lava perimeter looking like some Santa's belt on the sun before the Earth solidified and closed that suture. And as it turns out, this is not the case. The Earth's primary vortices along the equator are what formed that suture. And this is why we have from the northerly direction of travel, it's coming down through here, striking in here. And as we see that this one's coming this way and this one's coming this way, there's your two fish, right? You've got all of this stuff, all this material coming down through here and spilling into South America and forming up down here. And this vortex is rotating in a counterclockwise manner. And as it's rotating in a counterclockwise manner, it's forcing this suture to be formed into the shape of yin and yang. Okay, well, it's interesting stuff there, right? Then we go to this one, and we see how in the other vortex over here, the farther effort of this material is coming down this way and flowing down through Mexico, down into here. And there may have been some losses of mass, continental mass in here after certain events took place too. It's difficult to say at this point, right? Like something may have caused this great big hole right here. If you look at that as a whole, since this vortex is cutting right through between the two of them, and then cutting down through here. So this stuff spilled into South America and then followed down here and went all the way down to Antarctica. And you just keep going around the planet. Hawaii was an impact crater. So basically, what do you have? Why do the Hawaiian Islands go like this? So here's my theory. I don't have a theory on the impact crater that occurred right here. I'm going to show you where that impact crater was. So you see all these little spider trails going off into a radial fan right off. You see that little hole right there? That's the crater that created, that's where the impactor struck this part of the globe, and it had a wing blow out this way, a wing blow out right there, and then it had its burrow right here in the front pointing out this way. But basically what we have is, this is, you have like a linear volley, okay? So your volley is like when you're playing volleyball and you punt the ball up in the air and it's coming down. That's a volley. So your volley of rocks are coming down on the planet like this, and they're coming down at an angle. So this, my pinky, is going to be where that Hawaiian huge impactor struck, and then all of his buddies went right there and and created a line of ridges as they pummeled into the earth, as the earth was rotating at the time. Okay, that's how you get this string of shizzle schnizzle here, and we don't know if it necessarily has anything to do with this great big subterranean change over here or not, but it probably has to do with these guys, at least all of these guys right here. Okay, and this is spray that occurred from something that happened over here, right? And you have all this material getting sprayed out. That means whatever hit right here caused this part of the ocean floor to splatter like somebody threw a rock into the middle of a freshly cemented floor, and it just went splat and blew it out all over the floor. That's what happened here, okay? And that came from this over here. Hawaii came from down here, right? And then over here you have this great big, that's probably where this guy came from, because you have this great big B2W created by the monster that fell right here and created that peak. All right, here's your central peak, and here's your B2W. This central peak and B2W ratio are almost exactly the same as this central position and B2W over Guacanayabo. This is the Guacanayabo impactor. This is the North Pacific Oceanic impactor. And then we come over here, and the Indonesian vortex right here that makes the Earth look like the Death Star. You have the South China Sea impactor that occurred right in here. You see these little ripples? That's about where it happened. And they see these chain of islands coming out here because it broke up into a linear volley and struck the planet like this. And it sounded just like that too. I know, I was there. All right, so that's what you have right there, right? This is the way the planet goes. Now, we also know that this monster that struck right here more than likely was responsible for creating these guys right here. At least somebody did. Some great big monster impactor created a asthenospheric tsunami that traveled across beneath the oceanic bedrock through the layers of mantle, and then finally came across, and then as they emerged over here and created these helical vortices that formed into the Caribbean islands and the South Sandwich Islands. And whatever it was that did that did not affect the Galapagos Islands because they were already there, and it is igneous. If you want to survive a catastrophic event, find an igneous rock and stand on it. An igneous batholith, no less, and stand on it. And you might look as ugly as the, Komodo dragons, but at least you'll be alive, right? So, I'm going to go back over here, go back to this guy. Now, we're coming back over this way, and we see Indonesia, as it would have been affected by the first range of vortical operation, the oldest range that we can see. It wouldn't have been really the first, but it would have been the oldest that we can actually see scored into the earth. And so, there it is. And then you have Australia down here on its. They're out there. They're just out there flapping. They're like screw you. We're gonna rotate our own way. Yeah. So then that brings me down to this slide. Now I'm starting to break these things down. The different streams and rotations down to show people what it is that I'm looking at. Now, these yellow stripes are just generalizations of the streams, and as you can see, if this uppermost line was to be true, it would be arced in exactly the same way that our north polar vortical perimeter is arced right there. And all of them would be similarly arced by ratio as they reach the center of, and reducing the extent of the arc as they get closer toward the equator, right? But it gives you an idea of how these streams work, and short of doing that, I don't feel like sitting there stretching each of the lines out to make them work right. It would be, I could line them up with the perimeters here, but it would be a guessing game to figure out where they would be here, unless I just happen to be like right here. I'd skew it, and it would be right there on that score going right across the. Imagine that. That's in the Indian Ocean, folks, and it's right there. You see that line right there? He has a buddy over here somewhere, too. Yep. I'm trying to tell you. The Earth hasn't changed much. Alright, so this shows you how I was running my cursor down and how the precipitation for Africa in this particular vortical setting occurred. Then we're going to go to the next frame. This is our yin and yang vortical operation, and I described it. So you have your force, your precipitation taking place from Greenland down through Florida before becoming blocked by the B2W of Coconayabo here. And then you have the formation coming over here, down in here, and there's a relatively good chance that at this time this was all filled, the Mediterranean was land at this time, right? And so it came through up here. The vortices did not separate the Mediterranean, basically. And you have this coming down through. He curls down. He's running into this conflict right here, and he gets curled back into Africa and flows down this way into the African or the South African point. And then you have the other side, the western side of America, precipitating down through here in this vortical or this vortex, and coming down, sweeping down into South America and feeding a great mass down here. Don't exactly. We know that the Coconayabo. We don't know that the Coconayabo impactor at this point impacted before or after South America was developed. So the Coconayabo impactor could very well have been later. There might have been a greater mass of land coming all through here and flowing more evenly into South America until the Coconayabo came up here and smacked the crap out of it and basically created the Gulf of Mexico, and didn't necessarily create this. This was going to be created later by, more likely by South China Sea impactor. Then we go down here to the next slide, and this is the Pacific Seychelles Vortical rotation. And up here in this, I don't know, red and crimson are not very different, honestly, but I used crimson up here to mark the SESI North Polar Shock Release from the Atlapac fracture. Okay, I'm calling it the Atlapac fracture because basically I followed the fracture down through the Pacific Ocean, cutting through the north, and I believe they're connected, or at least at one time they were. So anyway, when this happened, you have the Aleutian Islands right here, and this force went around, swept up through the Aleutian Islands, came down here, and basically created the Rocky Mountains as it flowed down this way and fed into what was already being precipitated over here, further down into Central America, and then back down in here, creating the Andes. That was a really big rock. Well, it wasn't. It was big. It's smaller than the other two big rocks, Guacanayabo and North Pacific Oceanic impactors. But it had a bigger bang, and I'm thinking the bigger bang may have been because it might have been a great big block of ice. Ice on a hot molten mix is going to be pretty bad. I mean, that's like dropping cold water onto a very hot skillet and watch that water go. Yep, that's what it does. I know. I watched it on TV one day. So there we go. Now we're going to go down to the West Melanesian Seychelles because I couldn't find any other name to give it. And because it puts it right here in this area, and it's like there's no name for any of that stuff right there. And this is the really crazy part. Indonesia's the crazy stuff. So these red arrows are telling us the direction of rotation of our vortices, and this crimson arrow up here is showing us that it is basically this very same precipitation that occurred. It followed the precipitory lines and then created the Himalaya. Trying to figure out where the Himalaya is on this picture here. It's somewhere over here. All right. And it comes down just like that. And then you have the vortical rotation of the Indonesian vortex that was affected by the South China Sea impactor. And then you see how the crimson arrow follows through over here. This material gets pushed up. Australia was already in place, and this material flowed down and basically ran into Australia. So it goes all the way down here, comes around, goes all the way around, and keep wanting to call that Antarctica, Australia. And we follow it down here, and we see how the vortical rotation, this red arrow is showing us the vortical rotation of this particular vortex. And this is also basically a supplemental arrow in the same to show us the rotational direction. And then we go down here to the Fiji Islands, which creates a vortex here. And then we go down here, oops, my bad. We go down here to New Zealand, and we see how New Zealand's rotating in the opposite direction, just like gears. So you're coming down like this, you rotate like that, you go this way, you rotate like that, you go the other way, you rotate like that, you go down to Antarctica and you rotate like that. All works together, and then of course Australia is the black arrow that just decided to do its own thing. That's because it didn't have anything to do with any of this. This was Australia already existed. It was the result of Guacanayabo, right there, and we go all the way around the freaking planet, and bam, holy shit, there's Australia. And you see the vortical, the spiral density fracture for Australia. It starts about right here, it goes like a snail. All right, like a snail's shell. It's really hard to say. Alright, and this down here is just my model. There's my lithostream model stripes based on, oh, by the way, these guys, whoops, gotta go, whoop, went too far. Here. Do you see those guys? Oh my god. Yep, that's lithostream scores, people. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. That's an unusual number. No, it's not. Look at Jupiter. Not unusual at all. And I actually got a scientist, a really nice scientist. I liked her. I still like her, but it's not like we talk. I met her once and talked to her, and she raised her eyebrow when I suggested. At that time, I was only suggesting these fractures started over here further into the United States, and I believe that the mountains that appeared to have possibly been cone volcanoes at some point had something to do with these scores, and that these scores were like the Pacific Ocean. I was still on plate tectonics back then. The Pacific Ocean is moving across toward the west, running into Japan and pushing Japan up and all that stuff, right? And that these scores were actually extrusions, or scored by extruding out from underneath the American continent, until I did more research and began to lean more toward vortical tectonics. And then I mapped these guys all the way around the planet. And then you have, remarkably, the very same guys over here. It's like, well, that's interesting. I see. Now you notice how it kind of like disappears right there? And you got this guy so well formed here and disappears. Well, that's what I call planetary forensics, folks. Basically, this is giant guy molar number 1 and giant guy molar number 2, and based on his molars, we're like, well, this is what he looked like. His face was straight like this, and he had these really huge brows, and his jaw was mandibles like way out here, and he had 4 rows of teeth. So that's kind of like what we're doing right there, yeah? Forensics, planetary forensics. Well, where am I? I think I finished my presentation. So I know I'm boring, but it's the information that's good, right? So be sure to like my videos and subscribe. All right, I'm gonna go ahead and kill this one and plot it. Did I say plot? I don't know what I meant. I put it on there, and